Okay, my name is Clay Alexis Jarius. Today I will explain about two topics, which is, two questions, which is a function of function generator. That is my first question, and I will go through my first question first. For our information, a function generator is a device that can be produced various patterns of voltage at a very high frequency and amplitude. Most function generators allow us to generate sine, square, or triangular AC function signal. There are three terminals through which waveform can be applied to a circuit. The common, which is in the center of the terminal, provides a reference level of signal. The positive terminal provides a waveform in the positive direction from the neutral common. The negative terminal provides a waveform from the negative direction. Okay, now I will show you. In the multisim you can find the function generator from this, which is this one. And just now I already explained about the function of the function generator and also the terminal, which is positive, common, and negative. And this is the sine. This is the sine, square, and also the triangle. And if we double click, the display will pop up, and here we can set up the frequency and the amplitude. Okay, but here we need one more things to form our waveform, which is we call oscilloscope. And here here we must to connect the positive terminal to the channel of channel A. Okay, here we have two channels, which is channel A and channel B. If we want to form our waveform to channel A, we connect our terminal to channel A, and if we want to form our waveform to channel B, we connect our function generator to channel B. Here I want to form my waveform to channel A, and now in here common to negative, and we need a ground complete the circuit. In here, okay, here I will double click this oscilloscope, and the display will pop up. Okay, okay, now okay, before I start my presentation, I already said that I have two things that I will explain, which is first function of function generator, and this second is I will show how I determine the period and also the voltage peak to peak. And here from the left pole, which is the left pole, we are required to change the frequency to 2 kHz, 10 kHz, 50 kHz. and the amplitude is 3 V peak, and here 2 kilohertz, and amplitude 3 V peak. Okay, now here, as I said before, that the function generator has 3 waveform, which is sine, square, and triangular. And here, commonly, we are using the sine wave to see the one full cycle. Now I choose sine wave. Here I will run it first. Oh no, we have to change this to AC because we are using AC here. Now I click run, and now here we can see that this is the waveform that form, and we cannot see clear whether which one is the full cycle of this waveform. And here we must to change it, and this scale we must to change it to 1. This one, and you must to change it until it show the only the one full cycle. And here we cannot catch the waveform, and here we can change the waveform, which can select the singular, and now it will only show the permanent waveform. Okay, here I will explain by picture. Okay, just now we already set the frequency as 50 kilohertz, and I just take the example from the left port, and I set it as 50 kilohertz, the amplitude 3 volt peak. And here we see this is our the one full cycle of the waveform. And here we see that I changed the scale by 1 volt per division for the division is this box, one box. So here at the y-axis, which is here, we have 1, 2, 3 box. So 1 to 3 division, and one division has a 1 volt. So here we have 1, 2, 3 volt, and it is our amplitude actually. And here we already said that the amplitude is 3 volt peak. So here it will show us the amplitude of 3 volt. So the question asks to find the voltage peak to peak. So here we already has the voltage peak, which is 3 volt, and the voltage peak to peak is this peak from this peak to this peak. Okay, so this peak has 3 volt and this peak has 3 volt. So now we have 6 volt peak to peak. Okay, that is how I determine the voltage peak to peak. And now I will move to how to determine the period. Okay, here I have two different methods to determine the period, which is first I look at the x-axis, which is this one, here I put the scale of 2 U-second per division, which is division is 1 box. At this x-axis we have how many boxes? Okay, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 division. Okay, how to find the period by calculation? Okay, we have to multiply 2 U-second with this division, which is 10 division. So by calculation, 2 U-second multiplied by 10, we have 20 U-second. So 20 U-second period. Okay, so our period is 20 U-second. Okay, the second method is very simple. We just move this cursor, first cursor, to where the waveform starts, and the second cursor to the where the waveform ends. Okay, here the first cursor I put it at the where the waveform starts here, and the second to the way the waveform ends. So here the system will calculate the period for this one full cycle. So here it's already show us the period, which is 20 U-second, which is same as what we already get at the calculation method. So now I will prove that this is the exact value of the period. Okay, now we look at the frequency. From this period, we can get the value of frequency back, which is using the formula of f equal by 1 over period. So I will calculate 1 over period, which is period is 20 millisecond. So 50,000 hertz, and we can simplify by 50 kilohertz. So it's already show that the frequency that we set for this function generator will related to the waveform, which is here. The period of this one full cycle is 20, and if we divide 1 by 20 U-second, we will get the frequency that we set earlier. Okay, that is how I determine the voltage peak to peak and the period for this one full cycle. Okay, that's all from me. Thank you.
Good day, madam. I'm Dineswari Thanasakaran from BEEA Section 1 Group 2. Okay, so for Lab 4 assessment, I'll be explaining about the function of oscilloscope and also for part B. Okay, so for the function of oscilloscope, the oscilloscope or scopes, they actually display voltage signals as waveforms, visual representations of the variation of voltage over time. Okay, so the graph that is shown on the screen of oscilloscope can actually tell us many things, okay, such as the time and voltage values of a signal, and also the frequency of the oscillating signal, and from that we can actually also calculate the period of a wave that is formed in the oscilloscope. I mean, for one complete cycle of wave. Okay, so that's all for the function of oscilloscope. Okay, so now I'll show how to determine the phase angle for RC circuit, which is 10 microfarad. Okay, so for that I'll just use the circuit that I've created during lab session that day, and now I'll show you how to determine the phase angle. Okay, so first of all, we need to determine the period for signal from each channel first. So this one is for channel A, which is the input. Okay, so we got 500.942 microsecond, and this one is for channel B, which is the output. Okay, so we got 500.942 microsecond. Okay, so that one is for the period 0.942. Okay, so now we will start the we will find the difference in time for the starting point. Okay, so we got 126.177 microsecond. Okay, so to find out the phase angle, we need to use 360 degrees times 126.177 over the period of the both signals, which is 500.942, and we got 90.68 degrees. Okay, so which is this one. Okay, so this is what we got for 10 microfarad. Okay, so from this we can see that this one is channel B's one. The orange color signal is channel B's one, and the red color signal is channel A's one, which is channel A is for V in, voltage in, and channel B is for voltage out. Okay, so from here we can see that channel B, which is V out, actually leads V in, channel A, by 90.68 degree. Okay, okay, so now I'll show how to determine the phase angle for RL circuit using the 6 millihenry inductor. Okay, so just like capacitor just now, I'll just use the one that I have created for lab 4 that day. So I'll show how to find the phase angle. Okay, now we simulate it first. Okay, so to find out the period for channel A and channel B, we will do like how we did for capacitor. Okay, so we can take 499.058 microsecond for channel A, and for channel B Okay, so we try to take 500.942 for channel A also. Okay, so we can take 500.942 microsecond as a period. Okay, so as usual, to find out the phase angle, we need to find out the difference between the starting point of two waves. Okay, so the difference that we got is 92.279 microsecond. Okay, so as usual, we need to take 360 degrees and times with 92.279 microsecond over 500.942 microsecond. So we got 92. Okay, so we got 66.33 degrees. Yeah. 66.33 degrees as the phase angle for these two signals. Okay, so to find out the whether which one lags and which one leads, okay, so from here we can see that for the red one is the signal for V in, voltage in, and the orange one is for V out, voltage out. So from here we can see that voltage in V1 or V in, it actually leads by 66.33 degrees of V2. We can also see whether it lags or not. Okay, so if it's negative like this, so we can say that V just now is V in leads V out. So now V out lags V in. Okay,